Today we're going to talk about solving absolute value equations. So if you remember about absolute value, remember the absolute value of a number is the distance it is from zero on the number line. We always measure distance in a positive light, so that would mean that all of our answers when we talk about the absolute value will be a positive answer. So an absolute value equation is an equation that contains an absolute value expression. Here are three examples. So in the first example, we have the absolute value of x equals 2. So there is actually two answers to that. We would say that 2 is in the answer, because if I take the absolute value of 2, I get 2. But also negative 2 would be 2 when I take the absolute value. Then we're going to start looking at some more complicated questions. We have the absolute value of x plus 1 equals 5. And we're going to try to figure out how do we find out the answers to what is x equal. We also have the next one, which is 3 times the absolute value of 2x plus 1 equals the 6. And again, there's some more complicated things that we have to work through to make sure that we can do that. You can solve these types of equations by solving two related linear equations. So what we're going to do is take the one equation that we see with the absolute value expression and turn it into two similar linear equations. One will be equal to the negative and one will be equal to the positive to help us find the answer. So the key idea here is the following. If I read to solve the absolute value of ax plus b equals c, we're going to solve the related linear equations. What does that really mean? Well, the important part that you want to notice here in this is c has to be 0 or greater. I cannot solve the absolute value equations if I have c as a negative number. If you think about it, the absolute value of all numbers is going to turn out to be positive. So the c value will never be a negative. It could be 0, because the absolute value of 0 is 0, but I cannot take the absolute value of a negative number to get a negative answer. So these are the two related equations that we're going to be creating. What I'm basically going to be doing is I'm going to be isolating on any equation this absolute value expression and basically then setting it equal to the positive c or also the negative c and then solving from that point down. So let's just see how that works. In my first example, I see x minus 4 in the absolute value signs equals 6. So what I need to do is I need to take the x minus 4, which is the expression in the absolute value sign, and make it equal to 6 without the absolute value symbols. But what I also need to do is make the second related equation, because if x minus 4 equals negative 6, when I plug it in, the absolute value of negative 6 will also become 6. So at this point, I have two equations that I'm solving to help find the answer for one. We use our inverse operations to move the 4 to the right-hand side, so x equals 10. I use my inverse operations to add 4 to both sides. X equals negative 2. So here are our two answers that we think will work. So how do I know that they'll work? Well, I do my check. So if I plug in 10 for the x, subtract 4, and take the absolute value of 6 is 6. So that works. I move over to the second one. If I plug in negative 2 for the x and subtract 4, and I take the absolute value, I get negative 6, but the absolute value of negative 6 is 6, so it also works. So then I can say that my solutions are x equals 10 or negative 2. Okay, so moving on to the next example. So the next example, we have a little more of a complicated expression within the absolute value signs, but it's the same thing. But the very first thing I want to look at is there's a problem on the right-hand side. We just said from our big idea way up at the top that my absolute value, when it is by itself, cannot equal a number c that is less than 0. And we're trying to find an answer that's going to help us get something inside the absolute value symbol that once I take the absolute value becomes a negative. That's not possible. Anything that's going to come out of the absolute value signs is always going to be a positive number. So we answer this with no solution. Now, one thing that we got to make sure we don't do is we don't answer this as, oh, the answer is 0. 0 is a solution. We want to make sure that we say no solution. There is no x that I can plug in there that will give me any number that once I take the absolute value will give me a negative. So here we have another example. This one's got a little more work now. So we have the absolute value of 3x plus 9, but then on the outside we have a minus 10. So my very first step is that I need to isolate this absolute value expression. So the 10, or anything that's on the outside, has got to move first. So I'm going to add 10 to both sides. That's going to get me to this 3x plus 9 and the absolute value signs by itself. So notice on the last one we said, oh, we can't do this problem because it was a negative. What you don't want to do is look at this problem and feel like, well, I can't do this because it's a negative right up here. Because once we add the 10 to it, this right down here is where we want to ask, is C a positive or a negative? So back up here, yes, it's negative, but we still had this minus 10 to work with first. But once you've isolated the absolute value expression, that's when you can look here and say, well, is it positive or negative? And in this case, it's positive. So that means we can go forward. So what I'm going to do here is now create my two equations. I get 3x plus 9 equals the 6 for the positive equation. 3x plus 9 equals negative 6. Now I got a multi-step equation. This is where your SADMEP comes in play. First I want to move the 9, so I move the 9 by subtraction, and I'm going to get 3x equals negative 3. Then I would divide by 3 because it says to multiply by 3, and I'm going to get x equals negative 1. On the next one, again, I need to move the 9 first, so I subtract 9 from both sides, and I get 3x equals negative 15. And again, to undo times 3, I divide by 3, and x equals negative 5. So my solutions to this problem are negative 1 or negative 5. Both of those will make this equation work. So what I want to do next is have you try these two practice problems. You have a couple of examples to kind of look at and see. What you should do is pause the video, try those two examples, and then hit play again so you can see how you did. So here you have your two solutions worked out. So let's focus first on the left-hand side for letter A. So the very first thing you'll notice here is what we did was we had to isolate this expression. We subtracted 5 from both sides to get the x minus 2 expression with the absolute value signs by itself. At that point, we can move forward because the 4 is positive. We created our two equations. We used our inverse operations to solve for x. X equals 6 or negative 2. On the second one, there's a lot going on in this one. So the very first thing that some of us are going to think about is this negative, is that going to mean we can't do this? Well, we can't decide that until this piece right here is all by itself. So to get this by itself, I've got two numbers I'm moving, the negative 2 and the negative 3. Well, the negative 2 is multiplying by the group. The 3 is being subtracted. So by SADMEP, I'm going to add 3 first. That's going to get me to the negative 2 times the absolute value of x minus 1 equals negative 8. So again, this is still not a point where we decide that we can't do this. We have to go until this absolute value expression is completely by itself. So then I move the negative 2 by division because it says times the group. When I multiply it by the group, now we have this by itself. I can now focus on what is the C value. C value is a positive at this point, which means we can do it. So then we move into our two equations. I have 1 to the 4, 1 equal to the negative 4. I have a two-step equation, so I'm following SADMEP, and when I follow through, I get x equals 1 or negative 3/5. So just got to be careful with the absolute value equations that you want to make sure when the absolute value is completely isolated, that it is equaling a positive number for the C value. But you also need to make sure that you create your two equations once you have it isolated because your answer could be inside a negative, but it also could be a positive.